Welcome to the session, greeting of the day. In today's class, we are going to talk about the programmable logical devices. We have a few devices named as microprocessor, microcontroller or microcomputers, and the PLC, programmable logic controller. These three we are naming as a programmable logic devices. I have taken one example in the microprocessor or applications of microprocessor to see. On this I have taken an automatic camera. You see, we want to take a camera, we need to take a snap there. So I have a pulse rate, a send in, send out, and the microprocessor is there. Shutter button to press or off. Shutter button to be, when it is pressed, it is going to click. When it is released, it is going to release the snap has been taken. So who does this job? Microprocessor is doing. Microprocessor is doing, and the signals are sent when the shutter is pressed, button is pressed, microprocessor receives, and I want to take a photo, and the signal is sending there, and it rotates the motor to close. We are just clicking the button. Shutter has to be closed. Then the shutter motor is there. We have used the servo motors there to move, and therefore the lens position, zoom in, zoom out. So that all those things process are done. Brightness looking over, and all these things done by the microprocessor. How much brightness available, how much darkness are there, phase modifications, graphite background, depth. So those things are done, and we have taken the photo there. Similarly, in case this photo taking to the feedback again, you see, same shutter, microprocessor, signal conditioning, and the motor, lens, and the mask, all is then done. And this I am taking back as a feedback. So now it is converted into closed loop. I am converting as a closed loop, whether after receiving, we are seeing in the phones. We are not only taking, it is giving the information back. So this is what your lens, this is what your depth, this is what your brightness, contrast, and then after all modifications, feedback received, I am clicking the photo. And we are taking the image. So how it is done? It is done through the microprocessor analyzing, arithmetic logical analyzing are done there. How it is, the input given and output received. But in the remote, I need this channel pressing over, it receives the send is, information is sent there and it is changing. So whenever we need to change of programs in immediate, change of memories, there we are using this microprocessor setup. This is one example of automated camera. So this two setup, one is open loop and one is the closed loop setup. You see one more. So I have taken in the automated camera multiple operations I want to show you here. Here the main body of microprocessor is there for focus control. Focusing we are doing. What are the interfaces available along with this camera? We have seen here the motor, lens, and mask, and then this brightness contrast we have seen. Similarly, the same pattern I want to mention you. Lens interfaces, number one, lens interfaces are there. What are these? Local processors, focusing, apertures, zoom controls. These things are all done by the lens interfaces. Again, what are the other interfaces are available? User interfaces. Mode of selection, night modes, brightness, night mode we are doing, portrait mode we are doing. So such things are done by the user interfaces. So lens interfaces, user interfaces, and then one more also I'm considering here. I'm giving multiple tasks. My intention is to give multiple tasks to the microprocessor. One is the lens interfacing. I'm giving another task is user interfacing. Another task is flash interfacing. Local processor, flash shading, and then zooms and exposures. How much brightness? These are the just like that we have mentioned here simply lens positions. But that multiple tasks I am mentioning here. Three interfaces are attached to this microprocessor. One is attached here, and 2 and 3 are attached to do multiple tasks. Therefore, we are using this microprocessor as applications in the camera. So this you have to keep remember. The basic control system in a camera systems are it contains inside a microprocessor, a lens interfaces, flash interfaces, and user interfaces. We have seen a diagram which contains the center port of CPU, which contains the processor likewise. So we have taken a CPU of microprocessor. Here we have the first one. This is microprocessor I have written, number 1 and number 2, 3, 4. So 2 is lens interfaces and number 2 is flash interfaces. And number 4 is user interfaces. So these things are connected. So these are the inputs and outputs that we are going to do. User interfaces is giving the input, click. Flash interfaces are the output, lamp should be. And lens interfaces should adjust itself to zoom out. So those things to be done. So it contains a microprocessor to do the specific job. And also the various interfaces are connected. These are all known values. Depending upon the selected combination of lens interfacing and the flash interfacing, depending upon the input given by the user, microprocessor is going to activate the various actuators. So the parameters such as shutter speeds, see, combination of shutter speed, how fast, one photo or 2 photos, and focusings, otherwise the apertures automatically taken care by the microprocessor. According to the input given, those tasks are done by the microprocessors. On that automatic camera system consists of, now we may classify what are the operations can be done by the microprocessors and what it contains. It contains the drivers, shutter movement, closing, on, off, so driver motor to be there, and the sensors and interfaces. Now only we have seen 3 interfaces, phase interfaces. So these interfaces we have seen of lens interfaces, flash interfaces, and the user interfaces. So drivers like motors are required for shutter to movement. The sensors, this I am classifying here, and then the sensors I am classifying, and then user to be done. Sensors are essential for sensing what we are doing in the camera. Film speed, how fast one film is rolled to the next take, one take to the next take. Time counters, 1 second how many photos we have to take. And the focusing, defocusings, exposures, brightness, contrast, and the zooming in, zoom out. So those things are all sensed and given as the input to the microprocessor. Accordingly, whether it should zoom out or it is okay, all done in a second. So this user interfaces. So we have this thing, interfaces. Interfaces used to feed the information for achieving the desired composition. Which composition we need? Composition we are creating here. And the signals are attracted by these interfaces. And from the interfaces we are doing the various composition of parameters to take a single photo. When on take a photo, the microprocessor takes the input from the various range of sensors. Yes, now only we have seen, and sends the output to the lens and shutters to operate. The lens position is feedback to the microprocessor and gives an output to determine. Yes, the microprocessor again gives the output to the motor drive to take, open or close to take the photo. So such things we can able to do in the automatic camera system. Here we have microcontroller which contains inbuilt microprocessor, inbuilt RAM, inbuilt ROM, inbuilt input, inbuilt outputs. So one task, here this is all fixed. This all belong to fixed. And then I am taking you one more example of temperature control system. Similar to the automatic camera, I am taking the one more system of temperature control. There we have seen one of the example of washing machine also, sequential setups. There also we have used microprocessors. When to on, off, after washing, before washing, refinishing processes. So those things also comes under multiple operations, multiple tasks we are using the microprocessor. Additional RAMs, additional inputs, additional outputs, memory increasing, decreasing, program changing. So those things are done by the microprocessor. See here, now I want to do the temperature control. So temperature sensor is there, first options. Temperature sensor given us one input, and this temperature sensors having input, they have to be converted to analog to digital. Has been converted now. to the electrical formats, and this contains the Motorola microcontroller or microprocessor setup according to the number of operations. And then from here the timer counter also works. How long this temperature to be maintained, how long the counter to be maintained here. Thus we are doing some inputs are given, two inputs are given, one input from the sensor or the temperature, and how long timing we are fixing some to the programs, and then the output is taken to the storage registers, some memory are holding, and the functioning and we are seeing to the digital displays how much available. This is feedback. This, after seeing this, we can connect again to the same setup. So it is a closed loop. It can be converted as a closed loop. It can be converted as a closed loop system for digital displays. So this is about our temperature control. Some of the examples we should remember: washing machines, then the temperature controls, automated camera. These are applications of microprocessors. So this is how. So what I have done: temperature sensor sensed as an input, timing controller given as an input. So these inputs are converted to processes, and then the output has been stored in the memory. From the memory, we are going to the digital display and the functioning also, and the functions to control. So this is how we can able to do. This we have seen. These images we have already seen that the temperature sensor produces the analog signals, that is analog to digital converters we needed inside, which converts this analog to digital. The inbuilt program in the CPU converts this data to displaying the formats. The temperature will vary continuously during, see, the temperature is going to vary continuously. There we need a registered array temporary to display for a while. Then even though there the temperature is 59, we have to show, and in a second it changes to 60. We should analyze, we should record it in the computer, we should record it into the memory, permanent memories. So report we have to create. Therefore we need a storage register for a second to analyze or display to read it. So the temperature will vary continuously during the testing periods in a minute. So storage register is used. Here we are using the storage register. See here we are using storage register. By the diagram, here the temperature is sensed. After sensing the microcontroller which contains the microprocessor, we are using here as a Motorola company's microcontroller we are using. Here the input analog to digital, and then as usual timer counters, and the outputs are there. So these outputs are connected to the storage registers. Output is nothing but storage register to digital display. Here for a second a temperature of 98, a temperature of 88, it will display there. And then this storage register catches the second input. Next second's input as 88. Next second input as 77. So likewise it will take and displays. Therefore the temperature will vary continuously during the testing periods. Therefore storage register is used as one temporary storage device that holds the data for a period of time until the display is noted. It means recorded. I want to compare this to process of microcontroller. These ROMs we can able to change. The RAM we can able to change of about, you see, we can able to change up to from 4 to 6 to 16, and we are changing this. We decide how much we need according to the what program, how the big large data are there. It is therefore it is expensive also, and therefore it is widely used also, because it's not expensive. We are not using not like that. We are using versatile, because program we can modify. We should do task. Therefore it is widely used. But that's it. You see, it contains a fixed. It contains a desired. We can decide the amount of RAM, ROM, and input-output ports. Here one input, one output ports. Pen drive. We can consider this example of pen drive. So pen drive. So we can use only one input, one output. Here we can decide a computer. few computers may contain one or two, few computers may contain only 1, 4, 5, 6 multiples are there. So for applications in which about the microcontroller, the application in which the cost are compact devices only, less cost for only compact devices, one task, compact device. Space are critical, where we are not possible to insert microprocessor for specific one task. We no need to use a microprocessor, and also it is versatile. It is a very high expensive also. Therefore, I am using their spaces at congested space. We can able to use this microcontroller for specific one task. General purpose, therefore it is general reprogrammable general purpose, but here it is not like that. When it is programmed, it is useful for only one. That is a general purpose, not a single purpose setup. So applications, computers, mobiles, processors like i5, i7s, here applications are remote, mouse, players, as told earlier, all tools, toys and USB devices, and the ROM RAMs are there, are general purpose and a single purpose setups. It has many instructions, data to move between memory and the CPU. So here we are using unlimited, or otherwise we can able to change the amount of RAMs. Therefore it have more memories as like a computer. Therefore we can able to reprogram multiple programs we can operate. Therefore it has many instructions, many programs, many instructions, data to move between memory and CPU. But in the microcontroller it is a specific job. It has a 1 or 2 instructions only, specific job to operate, yes, no. Data to move between memory and the CPU. It has 1 or 2 instructions or data to move. But here there are many more instructions, many programs, many instructions. Access time for memory and input output are very high. It takes somehow a time consuming to respond back as we are giving more inputs to this. Accordingly, now we have using the latest processors, i5, i7s, and increasing the RAM capabilities, and therefore these options now also it become high. Access time is high, but now it is reduced and become quicker responses. But here, by the term, we have less responses, less responsive time, very quick. Access time is from memory to input outputs are very less, because only one instructions we are giving, and therefore immediately it is responding back. Here we are giving multiple responses, therefore it may take time. But now with respect to latest processors and with respect to addition of memories, we can able to make this high into less also. More hardwares are there, because it is not fixed amount. We can able to add, remove inputs, outputs, multiple inputs we can give, multiple outputs we can take, sensors and other side outputs we are taking, feedback signals. So there are more hardwares are there in the microprocessor, more instructions, more program, more input, more outputs. But here, microcontroller, less instructions, less programs, specific task, 1 or 2 hardwares, less hardwares. Therefore, it is also very reliable, but specific 1 or 2 jobs only. Accordingly, we should use. Here, more pins, therefore it having more pins, multi-functions, more instructions, more program, multi-functions. Here, less pin, single functions, or 1 or 2 functions. So likewise we can able to understand this comparison between microprocessor and microcontrollers. In this programmable logic devices, we have started to see about microprocessor, and then in this microprocessor we have seen some examples of washing machine, and then we have seen some examples of temperature control, and then also we have seen some examples of automatic focus camera, So likewise we have seen about this microprocessor, and also we have seen about the microcontrollers. This I have defined as a single chip. We just remember as a single chip contains all together at a one chip, at a single chip all together, it contains a single. So that is how we have defined this microprocessor microcontroller. Then we have seen the comparison between microprocessor and microcontroller. Microprocessor and microcontroller we have seen. So this is how we have done about this today's class. The remaining part of the subject we will see you in the next session. Thank you.